wolfSSL, for those that are new, our bread and butter is TLS. We're a lightweight and portable and C-based library, C library. We do have assembly optimization, as well as we can utilize hardware supported instruction sets. And we support up to TLS 1.3 as well as DTLS 1.3. The footprint is 20 to 100 kilobyte footprint. In terms of RAM session, which is really useful for embedded device. We occupy 1 to 36 kilobyte. Typically, a lot of people are familiar with OpenSSL because that's a default platform that comes on desktop. And we are 20 times smaller than OpenSSL. And we've got a long list of supported operating systems. We are certified in FIPS 140-2 as well as FIPS 140-3. We have DO-178C support, MISRA-C. It's the best really tested crypto. We provide 24/7 support. So if there are issues, you don't have to be on your own. We're dual license, and we've got a number of solutions, including Secure Boot, MQTT, SSH, TPM 2.0, GSSE, commercial support for curl. And we've got a number of hardware customers as well as partners. So the session for today is we'll briefly cover company overview, and I'll give you an introduction on DO-178C and how are we certifying our product here at wolfSSL. And we'll talk about the customer use case for wolfBoot on Tiger Lake. And wolfBoot solutions are a little complicated to certify and how we are achieving that. And then I'll give you a summary and open for Q&A. Well, how is wolfSSL library used? And we're used in pretty much all verticals, anything that needs security between two endpoints or security at rest, such as encryption. We've got medical devices company, automotive, industrial systems, Internet of Things, aviation would be the focus today, satellites, battlefield communications, appliances, electric grid, federal government, which we have our FIPS, validated cryptography, games, sensors, routers, connected home, application cloud services, printers, such as, the common printer use case would be like HP or databases, as well as smart energy. We're really trying to secure the internet by securing data. So the use case for our library is wide. So I've already covered this. So we can secure data at rest using our cryptography, which is an underpinning library that is leveraged by all of our other products. And then we can secure data in transit using TLS. The transfer medium is irrelevant for us because we run the application layer, so you can have TCP, UDP, Bluetooth, serial, even N-bus for aircraft. If you've got 1553 or some proprietary interfaces, we can support that because the medium doesn't really matter at our level. And we also support firmware update because using secure TLS as well as a secure boot. So this would prevent malicious firmware flashing and updates. Emma covers this one. And as far as our technology partners, there are a lot of silicon vendors as well as operating system manufacturers, such as Wind River Systems. We support VxWorks, and we run pretty much all available hardware in terms of architecture, PowerPC, ARM, x86, both 32-bit and 64-bit. as well as risk. And in terms of the DO-178C certified code, we have a subset of our cryptography certified in particular platforms configuration, as well as different tool chains. And we have a number of open source partners. If you actually go on our GitHub page, there's an OSP repository. You can see the list of open source projects that we support. And we've got pretty much a lot of the most popular open source project support wolfSSL. You could rip and replace whatever cryptography that comes with those open source software. And the advantage there is that since our cryptography has been FIPS 140-2 and FIPS 140-3 validated, you could leverage if you've got a requirement where you need to sell your devices to the government, then you can leverage our cryptography by replacing whatever cryptography that you are using existing. So far what we've talked about is wolfSSL and wolfCrypt, and wolfCrypt come in different flavors. The focus here is DO-178C. We have a number of other products that do different things, but the underpinning, the cryptography, is used by all of our products, including wolfMQTT, wolfSSH, wolfTPM, wolfBoot, wolfSentry, curl, tiny curl for data transfer. And we do support language wrappers. Although our library is written in C in assembly, we do provide wrappers for Java, C#, Python. I think that, as well as there was one additional one that I forgot. Oh, Rust is what I was. And we're a dual license, commercial license as well as open source. As open source GPL v2, you can go to our website, download, evaluate, test our library, do benchmarking, and if you cannot adhere to the open source licensing, then you can obtain a commercial license from us. We're a clean room SSL TLS and cryptography house. wolfSSL owns the copyright for all the code. And so when we do DO-178C certification, we take the open source version of our software, we trim it to the bare minimum that we need based on customer requirements, and we take it through a certification to generate artifacts. So I covered DO-178. When we talk about safety certification in certified system, the safety really is a freedom from unacceptable risk. And the certification is demonstration of the confidence in the safety of a system. And usually you get a stamp approval by an individual or a company that set of software meets the safety standard set by the respective agency responsible for guaranteeing safety in a particular industry. In the United States, it's the FAA that gives you the approval. And when we talk about certified system, it's a larger component. The FAA certifies airplane and engines and propellers, and the components are certified only as part of the airplane or the engine, the whole system. And software is part of the system component. And the requirement is every line of code must be clean and traceable to requirement and test for avionics, for anything that flies over the population. And why is DO-178C required? Well, it's a technical document. You can actually go to RTCA website and pull the document. And this document is put together from a consortium of people from the industry, government, and academia. And our DO-178C is not new. It's been around for a while, over 10 years, I think. I think the previous version, there was DO-178B and there was DO-178A. I think that came out in 82, the first one. So the RTCA, the Radio Technical Communication for Aeronautics, they published several documents, including DO-178 and others. And the focus for us is the DO-178C document. It's the primary document by which the certification authorities such as FAA, ESA, or Transport Canada approve all commercial software-based aerospace systems. So we've worked with DERS from Transport Canada as well as FAA on our projects. So if you open up the DO-178C document, you will see a list of objectives. So it provides guidance for production of software for airborne systems, and each objective for software life cycle process. And to accomplish the objective, there are activities you need to perform to provide a means for satisfying the objective. And the description of the evidence, software lifecycle data, including objectives have been satisfied, and the variation in objective independence, software lifecycle data control category is listed. And the number of objectives to be satisfied is determined on the spec. And some objects must be satisfied with independence. When we say independence, verification activity is performed by a person other than the developer of the item being verified. Person who created a set of low-level requirement-based test case should not be the same person who developed the associated source code from those requirements. So there is a lot of paperwork as well as independence, and it requires a lot of manpower to generate the artifacts to ensure that the software is pretty safe and solid. For the design assurance, there are 5 different design assurance levels with DO-178C. And software can be certified under any of the A through E, depending on a failure condition. Right now, our source code, the open source code, is at level E, right? And but we've done a number of certification, wolfCrypt, different algorithms under level A. For level A, there are in that document, the DO-178C document, if you look at it, there are 71 objectives, and 30 of the 71 require independence. And when we talk about level A failure condition that is catastrophic, failure will result in death, it will loss of airplane. So most of the time when software is written, a lot of people are a little easy on in terms of what would the software doing when something goes wrong, right? But for a DO-178C certified code, that is very important to be able to handle a case when the software is not performing what it needs to perform. And there are different levels. Most of our cryptography is certified to level A, and for the other levels, there are less objectives. So in the DO-178C objectives are listed in the document. You can categorize them based on the number of objectives and what they are related to. Some are software planning process, software development process, verification of output of software requirement. You've got 7. The most one is the verification of output of software design process, 13 objectives related to that. Verification of output of software coding and integration process is 9, and so on and so forth. So for software configuration management, as an example, there are six objectives. To be able to get credit for 71 objective for DAL A, you have to have activity that satisfy for each objectives. And what's important for DO-178C is to be able to generate traceability. It requires bidirectional traceability between certification artifacts. So starting from traceability evidence can show direct relationship between high-level requirement to low-level requirements, and line of source code that implement the requirements. In test case, meant to verify source code correctness and result of test. And depending on which DAL level that you want to certify, this diagram illustrates for DAL A, which is the black arrow here, and for ABCD as the legend, the green one. You can trace it. So for our CDP kit, certification data package kit, which is off the shelf, we've got DAL A, and you would open the document, which is an HTML index.html file, and you could browse from the top level all the way to the test results, including the code in the design document and the requirements, right? So in terms of DO-178 certification artifacts, there need to be a linkage between requirement, design, source code, test procedure, and test result, and each one need to be reviewed and documented. And there are criteria of what the requirement need to satisfy, the design need to satisfy, the source code need to satisfy. Source code would be like a design coding standard as an example of this procedure, same thing. And all those are called artifacts. And typically our strategy for generating certification artifact is we work with the certification lab, because DO-178C projects require a lot of manpower, as well as expertise, as well as infrastructure. You have to have the infrastructure to be able to, and the tools to be able to generate certification data package, as well as, in the future, if there are modifications that need to be made, you want to be able to automate and can easily respin a CDP kit. For that reason, we work with the certification lab. Usually when we kick off the project, we would sit with the customer and collect their requirement. And once we do, we engage the certification lab after we trim the code. Our code base is pretty huge. I mean, we've got over 300 options. And for DO-178C, you need to have a specific configuration, as well as you cannot have dead code. So we trim the code. That process typically take about a week, maybe a little bit more if the algorithms that are selected are huge. And then once we've got the code prep, we engage the certification lab. Yeah, but we will be responsible for fixing and maintaining the code. And the lab would file problem reports, certification related or documentation related, and we fix it. And you will see a requirement coverage, and the lab would perform a structural coverage analysis. See this modified condition decision coverage for DAL A. It necessitates the need for requirement-based test cases, which will be included in the certification data package as well. And once all this are satisfied, and this process typically take 2 months to 9 or 10 months, depending on the software, how many lines of code you're trying to certify. And to just give you an idea, we've certified around I think the largest that we've done is about 14,000 lines of code, and that took about 5 to 6 months. And essentially, the deliverable to the customer would be a certification data package as hyperlinked media, ISO image, or a zip file containing all the artifacts, and you can just open the index.html file and navigate from the high-level requirement all the way to the test results. And it also includes the source code as well as the object file. So your application would link with the big .o object file that is in the CDP kit. If you want to recreate the process, then all that documentation will be available. And we do support certification audit. The certification authority work through at a minimum this stage of involvement, SOI, when reviewing a system or subsystem. And depending on our arrangement, we can support SOI support in terms of the delivery as well as when we work with customers. Some customers want the certification data package at the end of the SOI when we finalize it. Some want to receive deliverable like SOI 1 or SOI 2, SOI 3, SOI 4 in a separately, because while it is being delivered, it could get reviewed by the customer. And the SOI audits really is a document for software approval guidance. So the FAA defines what the SOI requirements are. And for SOI 1, all the software planning document review have to be completed. And for software development review need to be completed on SOI 2. And partials in terms of the software aspect of it, I think 80% of it, 60% of it need to be completed for SOI 2. And then during SOI 3, 100% of the code need to be developed and verified. And finally, you get the final certification software review. The SOI 4 would be the last deliverable. For DO-178C wolfSSL Product Certification, we're really a top-class software safety. It does not, software safety does not imply security, not vice versa. And security software must also be safe. So for DO-178C, there is no dynamic memory allocation, and we really need to have a predictable execution flow. And safe code must also follow cybersecurity best guidelines and standards. And usually ancient mentality is if it ain't broken, don't fix it. And the new paradigm based on vulnerability management is when something breaks, be prepared to fix it. So we've got a pretty solid, top of the line, tested security software, and we generate certification evidence for it to make it safe. And we make code changes. If there are dynamic memory allocations, we rewrite those as well. And then we clean up the code and we add parameter checking and clean return code documentation and so on. So wolfCrypt has completed Do-178C DAL A certification for cryptographic primitive used in secure boot, firmware update, and secure transport application. These are the algorithms that have gone through a certification. Our first Do-178C certified cryptography was released in 2000. So that's been 5 years. And it included hashing, SHA-256, RSA sign verify, encryption decryption, AES CBC encryption decryption, and ChaCha 20 poly 1305. So that was the first certified cryptography. Since then, we've incrementally added, based on customer requirement, incrementally added more algorithms, including different modes like AES 256 GCM, ECC 384, with curve 256, both for sign, verify, and share secret, as well as ECC key transport. We've also added X509 cert verify, as well as a certification revocation list. We had a customer interested in the CRL. The CRL was written in a way that it could only be used with our TLS library, but we've worked with the customer, and we've cleaned it up and taken it through a certification at the wolfCrypt layer. So it's trimmed down and polished up to work at the lower layer as opposed to the TLS layer. And we've also added, we also have support for HMAC and CMAC in different key sizes. So those are available for different architectures, depending on your need. We're here to support you. It can be expanded or trimmed as needed based on customer requirement. So wolfCrypt has also been FIPS 142 validated, and 140-3 upcoming. This needs updating. Actually, we did get our FIPS 140-3 certificate, I think last June, if my memory serves me right. And prior to that, we had FIPS 140-2, and at the time we had 77 operational environment listed, and for FIPS 140-3, it's about that many, if not more, listed. And new OEs can easily and quickly be added to existing wolfCrypt FIPS certification. So as part of the FIPS validation process, wolfCrypt undergoes CAVP and ACVP algorithm vector testing. So what this gives us is that we're using the same cryptography, the same software that has gone through FIPS 140-2 and FIPS 140-3. And then we take that and trim it, and then take it through DO-178C certification. So the process is, in terms of the development or the cleaning up of the code or the trimming of the code, is smoother, because we're talking about a cryptography that has been tested many times and have gone through FIPS validation. In terms of outside wolfCrypt, so our approach for DO-178C certification has been doing incremental CDP cuts based on customer requirement, and ultimately get like a TLS certification at the communication level. And we're talking about lots of lines of code, and as well as other products such as wolfBoot. So this wolfBoot is currently going through DO-178C DAL A certification, to be used for secure boot on 11th gen Intel Core based on Avionics systems. And files currently in certification boundaries are listed here. And we were talking about 60,000 lines of code, I think, altogether. Yeah, about 60,000 lines of code, including the wolfCrypt. So the wolfCrypt is underpinning cryptography, and most of it has gone through DO-178C certification. So we're just reusing that. And then you've got the newer code, which is the wolfBoot specific code. Isn't much, maybe it's like 1,500 to 2,000 lines of code. And wolfBoot has been written for portability and ease of audits. It's written in C for bare metal use up to larger systems, integrates into an existing bare metal RTOS or OS solution, support multi-boot, ELF, Linux support. We abstract out HAL design for CPU speed and flash. So it really reduce target the specific code to the minimum. If you look at the target specific code, is for flash locking, unlocking, reading, and writing, which is really minimum. If you go on our wolfBoot repository, you can see examples of it or the code. And it's a small footprint, easy to audit, able to run on embedded devices. And wolfBoot DO-178C supports 11th Gen Intel Core i7 processor, can run inside UEFI environment, then load and verify other EFI application. Linux supports booting as an EFI application example. It also support other popular architecture. While this is going through DO-178C certification, we do have support for ARM Cortex-M, ARM Cortex-R, ARM Cortex-A, 64-bit, both Intel 32-bit as well as 64-bit, and RISC-V 32-bit, and PowerPC 32 and 64-bit. And the wolfBoot features relies on wolfCrypt, our FIPS certified crypto engine, and DO-178C DAL A certified crypto algorithms. We support asymmetric verify using ECC, RSA, ED 25519 or ED 448. In addition to this algorithms, by the way, our products do support post-quantum algorithms, the ones that have been approved by NIST. And those are available if you want to use them. And wolfBoot features, it provides a public key-based root of trust with multiple keys. Loader handles update between partition, like for power failsafe, and update failure rollback and version downgrade protection is supported. We've got support for external flash memories. That's very important because if you don't have enough flash, you can't do much. And it supports bootloader self-update, not power failsafe. We also do support encrypted updates as well as Delta updates. Typically for wolfBoot key management, so key pair is generated once, the private key always on a server, never shared, public key stored on a target for bootloader access. No revocation of public key except for bootloader update. Security relies on unique private key for cloud backend update signing. Sign tool attached a manifestator to the image. The manifest used to validate image integrity and authenticity. And the firmware version is also part of the verify payload. And we do this because to prevent rollback attack and cannot be altered without the key. And wolfBoot relies on a trusted anchor to embed the public key used to verify the signature. Sometimes you can use wolfTPM with wolfBoot as a trusted anchor. In terms of the boot strategy, we have AB update or boot and update strategy. The AB update, we have two partitions in a non-volatile memory and shares the same hierarchical level. New update goes to the unused partition. Old firmware is kept for fallback. And for the boot update mechanism, active firmware always boots from one partition, updates stored in a second partition, content of partition is swapped during installation, and second is swapped during fallback. So while the AB suits position independent firmware, but not recommended for microcontrollers with physical memory mapping and XIP constraint D2 compile time, execution in place, limitation, and external NVM restrictions. So for microcontrollers, you want to be using the boot and update. And wolfTPM is currently going through DO-178C DAL A certification to be used for certified TPM 2.0 usage. And files currently in certification boundary are listed here. I think we're talking about 4,000 lines of code. Let me double check. Yeah. About 4,000 lines of code. Yeah, so Yeah, so we're taking wolfBoot through certification, wolfTPM through certification. We've taken wolfCrypt through certification. wolfCrypt is leveraged in wolfTPM as well. You can use, you don't necessarily need to use wolfCrypt with wolfTPM because wolfTPM functionality provides cryptography capabilities. So to minimize code base, we just taking wolfTPM through certification without the wolfCrypt. So Secure Boot can help prevent your avionics system from becoming $1 million brick. And wolfTPM TPM 2.0 library is a lightweight TPM 2.0 library. They are implemented per TCG specification. We support both SPI as well as I2C communication. Design allows for easy portability to different platforms. It's a native C code designed for embedded use, single I/O callback for hardware interfaces, no external dependencies, and compact code size and minimum memory use. And we do have HAL examples for Raspberry Pi, STM32 CubeMX, HAL Atmel. It's tested on ST33TP, SPI, I2C, and Infineon Optica SLB9670. So for the use case, the avionics system using Tiger Lake, the 11th gen Intel Core i7 processor, why use wolfBoot? Well, the customer requirements were verification of all components used in the boot process, including the Intel firmware support package, binaries, and configuration. And they want to interact with the SATA drive for secure disk unlocking, using the TPM 2.0 for sealing and unsealing disk secret based on system measurements. So so the use case is leveraging TPM, as well as PCI dynamic enumeration with runtime discovery, and use the Intel boot guard used to implement root of trust and root of measurement, and support for multiple operating system protocol formats. So in order to accomplish all this and want to leverage the cryptography that have gone through FIPS 140-2 and -3 certification and trimmed and gone through DO-178C certification, as well as the performance aspect of it as well. If your hardware is able to provide hardware acceleration support to be able to leverage that, you want to use our wolfBoot solution. So for the firmware support package is responsible for initializing memory controller and preparing memory sections. It's in charge of silicon initialization and complete and easy customization of the silicon. So we do have an agreement with Intel, and they provided the firmware support package for us to use with our wolfBoot solution. And the Intel boot guard provides root of trust for verification and measurement of the boot process. Requires a few Intel specific ingredients. The PCI and peripheral initialization requires bootloader support for dynamic device enumeration. So this is a diagram of our two bootloaders. There are, when you build the wolfBoot, there is a stage 1 as well as a stage 2, and the flow is that execution start from a reset vector. So the green image is signed with Intel tools and verified by Intel boot guard, like the wolfBoot stage 1, FSP, FSP temp, and FSP memory. All this are signed by Intel tools. And then wolfBoot to stage 1 will load and execute Intel FSP. Memory is initialized by FSP, verifies authenticity of the last FSP, contains initialization for specific silicon, and it verifies our wolfBoot to stage 2. And then from there, our wolfBoot to stage 2 selects an image to boot and verifies authenticity of the image using the payload, which tells it which algorithm, whether it's using ACC 384 with SHA-256, and then verifies it, and it loads in the stage to OS. So the orange one is verified by stage 1, and the blue one is verified by stage 2. So the benefit of wolfBoot is performance. For example, on x86, you've got the Intel AVX2, which accelerates SHA-256 and SHA-2 so you can leverage that, or Intel AES-NI for faster encryption and decryption of encrypted images. And for DO-178C certification, certified security boot solution, and ability to integrate a special feature into boot sequence. So for example, you can replace Intel Slim bootloader, use wolfBoot as a second stage bootloader to Intel BootGuard, use sealing and unsealing password from TPM 2.0 to unlock the SATA drive and host boot OS image. So we've done a number of replacement modification to replace Intel Slim bootloader with the customer. The modification done to wolfBoot to allow it to act as an easy replacement. To add Intel FSP microcode API support, stage 1 memory initialization loader, watchdog, UART, and SPI drivers, multiple sign partition support, multi-boot and ELF32 support, power on built-in test, those pbit test, test different functionality during power on, and the TPM base root of trust in major boot, where we would store the secret that is used to unlock the SATA drive and SATA drive unlocking. So Wolf team can easily make changes to wolfBoot to meet your avionics secure boot needs. This is a complex project, and depending on your requirements, we're here to support you, small or big. So as far as we know, wolfCrypt plus wolfBoot is the only DO-178C certified secure bootloader solution available today that we know about. And why replace your existing bootloader with wolfBoot? DO-178C certified crypto and bootloader code, FIPS 140-2-3 validated cryptography, CAVP, ACVP validated cryptography, hardware-based cryptography or platform-specific assembly, secure key storage, TPM 2.0 solution, really smooth integration with TPM 2.0 solution, and customizable boot process integration. So what does wolfSSL DO-178C product mean for you? So easily meet your DO-178C certification requirement for general cryptography use. For example, for message digest, use SHA, hashing different sizes. For sign and verify, use RSA or ECC, different key sizes. For encryption and decryption, use AES, different modes, CBC or GCM, or different key sizes, or Cha-Cha Poly as well. And you can use secure boot or secure firmware update. Secure key storage, you use TPM 2.0 module. And wolfSSL team actively maintains support this product with support package up to 24/7 levels. And keep costs at a minimum. wolfSSL team works with each DO-178C customer to trim down the minimum required. Code trimming, reduce line of count to minimum for lowest cost certification. Yeah, this is it. So secure boot prevents running unauthorized software on board. Cryptography signature attached to all authorized software. Secure bootloader will refuse to run non-authentic code. And this one was extra slide. So today we've covered about DO-178C, high level, what DO-178C means. There are 71 objectives. And our cryptography has gone through DAL A certification, and we've taken an incremental approach, initially releasing our first DO-178C certification data package 5 years ago. Since then, we've added a number of cryptography primitives for different architectures and for different tool chains. And we've taken an incremental approach of now taking wolfBoot, which is a product on a Tiger Lake through certification to replace the Intel Slim bootloader. And we've covered wolfTPM, which can be used to for sealing and unsealing secret or for major boot. We are taking wolfTPM through certification as well. And we covered, we do provide 24/7 support, and our strategy for generating certification evidence is to work with a reputable certification lab to generate the CDP kit, and that summarizes it all. And I will be open for questions now.
Wonderful. We're going to dive right into the questions. Starting off, what is the requirement on hardware for wolfBoot to work?
It depends on your hardware. It can be bare metal, or like the x86 target. So we do support, ARM, PowerPC, x86.
Awesome. Is rollback a concern with having fallback firmware?
No, because for the rollback on your server, you would be using your private key and include the version number. So once you have the version number included in your payload, and that is signed by the private key, and the public key that is available on your target will check the version number has been increased. If not, you would fail.
Gotcha. For which CPU architectures has wolfCrypt achieved DO-178C certification?
Let me see. Quite a lot. So in terms of hardware, we've NXP, PowerPC, MPC 5566. We've taken it through Xilinx, UltraScale on A53. Let's see, Intel Tiger Lake, Xilinx, Zinc 7000, ARM 64-bit Cortex 7, for different compiler. Obviously, for DO-178C, you also need the compiler is important. So we've taken a combination of Wind River DIAP compiler with Green Hills GCC compiler, as well as ARM Developer Studio compiler. Those are the, so yeah, in terms of architectures, PowerPC, ARM, and Intel.
Wonderful. Where can I find your DO-178 source code or certification data packages?
Yeah, so while we are dual license, open source as well as commercial license, our DO-178C certification data package is not available on the website. But if you do contact us, we'll be happy to give you a tour of what the CDP kit would look like and what your requirements are. But the code itself is not available.
For compliance with DO-178C, top-level requirements are needed. In case of equipment, they are system requirements allocated to software. With component software such as wolfCrypt, what are the top-level requirements?
Now, that's a very good question. So the top-level requirements for our cryptography are based on the RFCs. So, for example, SHA-256.
Perfect.
Yeah.
Well, I think that finishes off our questions. Oh, are you still answering that one?
Yeah, I mean,
Okay.
that was a very good question because when I initially worked on the project, I kind of struggled to come up with the requirement, but because it's already written, really, right? So there are RFCs for algorithms. For example, this one is for SHA-256. There is an RFC request for comment documents that are available, and then the requirements are based on this document.